Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about voltage regulation of transformer and its related problems. First, what do you mean by voltage regulation? Voltage regulation is a measure of change in the voltage magnitude between sending and receiving end of the equipment. So this is for all machines. So first, if you see the definition, first voltage regulation means percentage voltage regulation means voltage difference between no load and full load voltages of transformer with respect to its full load voltage. So here E2 minus V2 divided by V2 into 100. So now here if you draw the transformer here, so first one, this is the transformer side. The winding which is connected to the transformer is known as the primary winding turns are N1, and the winding which is connected to the load is known as the secondary winding. The secondary winding turns are N2. So this primary winding voltage is V1 and primary current is I1. Now here induced EMF will be developed in the secondary winding. So that is E2 and E1 according to the Faraday's law of electromagnetic induction. So induced EMF, mutual inductance concept. Induced EMF will be developed in the primary winding, that is E1, self-induced EMF, and this is the mutually induced EMF. Now here, if initially there is no load, so no load voltage is E2 only, this E2, and if you connect the load, there is a voltage drop here, V2. This one. So this is V2. Now here voltage difference from no load to full load. Initially there is no load, that no load voltage that is E2 and full load voltage of V2 of transformer with respect to the full load voltage, that is V2. So now here voltage regulation of transformer, first I will explain. There are three types of loads here: lagging load, leading load, and resistive load. Lagging load means inductive load, leading load means capacitive load. First I will explain for lagging load power factor. Lagging load power factor for that one is cos phi theta 2, the angle between secondary current, this current I2, and this secondary voltage V2 and I2 is theta 2. Now here voltage regulation formula, V no load E2 minus V2 divided by V2 into 100, percentage voltage regulation. Now here E2, I2 and V2 and that resistive, depending on this impedance is Z equals to R2 plus JX2, this is the Z2. So now here for this one, this is the vector diagram for voltage regulation of transformer. So E2, so first I will draw the diagram. Transformer E1, E2, so primary turns N1, N2, and this is the primary winding voltage V1, this is the I1, and this one is the E2, and this, if you connect the load, this is the V2 and this is the I2. So this impedance equals to Z equals to R2 plus JX2, and this impedance equals to R1 plus JX1, so that is Z1. So now all these parameters, now in this again, so first phi as a reference, flux, it is a constant flux device, phi is a reference, and I1, this is primary I1 is divided into two parts, I0 and I1 dash, primary counterbalancing current, and this is the V1, and this is V1, and this my E1, and this V1, this is the E1, and this is I1 R1 and I1 JX1, and this part is most important. This is E2. So this E2 plus this E2 equals to this V2 plus I2 R2 plus JX2, I2 V2 plus this V2 plus I2 R2 plus and I2 X2 equals to this E2. So this diagram. So now I am representing this vector diagram like this. So now this is most important. This one and this one is same. So now this V2 equals to this V2 equals to, so this V2 is this one, this V2 is this one, and next I2R2, I2R2, next I2X2, next I2X2, and this is E2, this is E2, and this I2 is here. So same diagram. So I am representing for derivation purpose regulation of transformer. So now here this I am extending this OA to OC in this. So now here draw the vertical line. So this is up to A to B, and if you draw the vertical line, so perpendicular lines, it is B and this is E, and next draw the horizontal line to here and draw the vertical line here. This is theta 2, this is theta 2 power factor, and this is theta 2, and this is the delta. Now from this diagram you can derive the voltage regulation of transformer. Here voltage regulation of transformer means E2 minus V2 we need here. So now here E2 minus V2, here E2 minus V2. So from this you can, this is the voltage drop from no load to, so what is the drop between these? So that equation I am deriving here. So first this is diagram. Now here OC equals to this, OC equals to OA plus AB plus and BC. So this OC equals to OA plus AB plus and BC. So it is a straight line. It is divided into three parts: OA, AB and AC. Here OA represents here V2. This one here OA represent is V2, and next AB represents here. AB represents here. So now here AB is equals to, and this is the diagonal, and this AB equals to, this is theta. This theta means this I2R2 AE cos phi 2, this one, and AE equals to I2R2 cos theta 2, not phi 2, cos theta 2. And next here this BC equals to, this BC equals to, can I write this one DE? So D and E, DE, this is the diagonal, and so this one, and BC equals to, and EF, BC equals to EF here. So now this one equals to BC equals to EF, both are same horizontal, and next this one equals to this DE and sin theta 2. So for that equals to X2 I2 X2, DE means I2 X2 sin theta 2. Now here OC and OD, OC and OD here, OC, this OC and OD all are of same, of almost same. Angle between OC and OD is very small. So it is very small means almost, so we can OD and OC is approximately equal. If angle is very less means it is OC equals to OD. We can write this one. Okay, if this angle is very small. Now here OC. OC means here E2. E2 equals to OC equals to OA plus AB plus BC. OC equals to OD. I can write this one. OC equals to OD. OD means this is E2. This is E2. So OD equals to E2. OC, OD same. OC equals to OD if delta value is very small. If that one equals to E2, okay, I can write this one as the E2, and OC equals to OA plus AB plus BC. Here OA equals to V2 and AB equals to I2 R2 cos phi 2 and BC equals to I2 X2 sin phi 2. So now here this is E2. So from this I can write this equation as this one. Here I am writing E2 minus V2 equals to I2 R2 cos phi 2 theta 2 plus I2 X2 sin theta 2. So this is the resistive voltage drop. So from no load to the full load. So now here voltage regulation of transformer at lagging power factor E2 minus V2. So E2 minus V2 is this one. E2 minus V2 equals to I2 R2 cos theta 2 plus I2 X2 sin theta 2. So divided by V2. So now here E2 minus V2 is this one. I can write this E2 minus V2 equals to I2 R2, this one I2 R2 plus cos phi theta 2 plus I2 X2 sin theta 2, this one, and divided by V2. This is the final equation for voltage regulation of transformer. So now here, so for leading power factor case, so this current leads voltage by some angle theta 2. So this angle is theta 2. In the previous case, this I2 is here, that is lagging power factor theta 2. So here leading power factor case, the diagram it looks like this. So for final conclusion here, for lagging case, so it is plus, and for leading case it is minus. Everything remaining is same formula, I2 R2 cos phi 2, and plus for lagging and minus for leading, and I2 X2 cos sin theta 2 into 100 divided by V2. Here plus for lagging power factor and minus for leading power factor. So this is the formula for voltage regulation of power factor transformer. So now let us take one problem. Now here the transformer secondary output voltage is 220 volts at no load, and when voltage decreases from 220 volts to 210 volts when transformer is loaded up to its full load capacity. So first draw the diagram. So this is the transformer. So at no load voltage 220 volts. If there is no load, this is V1 and this is E2. So now initially it was 220 volts at no load, and if you connect the load, so if you connect the load, this load voltage is 210, it drops 10 volts. So now for this case, the given data E2 equals to 220 volts and V2 equals to 210 volts. So if you know this, and you can write the this percentage voltage regulation equals to V2 E2 minus V2 divided by and V2. This is E2 minus V2 divided by V2 into 100, that is the percentage regulation. This is the formula. So now here the difference is here 10 by 220 to 210, that equals to the simplified value. The final value is 4.76. The voltage regulation of this transformer when voltage is decreases from 220 volts to 210 volts when transformer is loaded up to full load current capacity, that value is 4.76 percentage. And next, a certain transformer has a no load open circuit voltage 120 volts and voltage drops to 110 volts when load is applied. Calculate the percentage voltage regulation of transformer. Now here same thing here, this E2 equals to 120, and if you connect the load, this is a 110. So now for this case same solution, 120 E2 minus 110 V2 divided by V2, that value is 8.33 percentage regulation. Now here next problem, a 10 kVA single phase transformer provides a no load secondary voltage of 110 volts if the equivalent secondary winding resistance is 0.015 ohms and its total reactance is 0.04 ohms, and determine its voltage regulation when supplying a load at 0.85 power factor lag. So first solution for this one, given data first. What is the given data here? So no loads E2 equals to 110. This one holds. Next, and R2 equals to 0.015 ohms and X2 equals to 0.04 ohms, R2 X2, and cos phi 2 equals 0.085. So from this you can find out phi 2 value and sin phi 2 value. So now here voltage, we need, what is the formula? Voltage regulation formula I2 R2 and cos phi 2 plus or minus sin I2 X2 sin theta 2 divided by V2 into 100, and percentage regulation is equal. This one equals to. Now here R2 is okay and V2 equals okay. Cos phi 2 value is given. From this cos phi 2 determine sin phi 2, and next I2 value can be calculated here like this. Cos phi 2 means, so cos phi is 0.5 and phi equals to 31. Cos inverse of 0.85 equals to 31.8 degrees. So sin 31.8 degrees equals to 0.527. This one. And next here I2 value equals I2 equals to KVA rating is 10 kVA. 10 kVA means 10 into 10 power 3, this one, and divided by this secondary voltage E2 equals to, that is 110 volts, that equals to 90.9 amperes, this one. Now this is the I2 secondary current. IS indicates the secondary current. So now from this you can easily calculate. Here S indicates the secondary current, that means I2 R2 and cos phi 2 I2 X2 sin phi 2, and this is a V2. So now here substitute in this. So this is the I2, this one, and next this is the R2, this one, and this is cos phi 2, this one. Next, this is for lagging power factor. For lagging power factor case, voltage regulation is here plus. For leading power factor it is minus. So it is lagging power factor means consider only plus. And next this is X2, I2 X2, and next this is the sin phi 2, and this is the cos phi 2, and this is V2. So now simplify this one, and that this numerator value is 3.075 and denominator is as it is 110, and 3.075 into 100 divided by 110 equals to 2.8. This percentage regulation, voltage regulation of this transformer from no load voltage 110 volts to this one, that voltage regulation is 2.8 percentage. And next, last problem, this one, this is most important. Next, a 100 kVA transformer, a single phase transformer, has primary turns, 400 primary turns, N1 equals to 400, and 80 turns on secondary turns, and N2 equals to 80. So the primary and secondary resistances 0.3 and 0.01 ohms respectively, and the corresponding leakage reactances are 1.1 ohm, this one, and 0.035 ohms respectively. The supply voltage is 2200 volts, and calculate the equivalent impedance referred to the primary and the voltage regulation and secondary terminal voltage for full load having power factor 0.8. So now here we need what are the terms? So percentage regulation formula. So voltage regulation formula I am writing here. So percentage regulation formula equals to percentage voltage regulation formula equals to I2 R2 cos phi 2 plus or minus, plus for lagging and minus for leading. So here minus not required, it is only leading power factor, and I2 x2 sin phi 2 divided by V2 into 100. So now here what are the parameters we need, and R2. R2 is here. So given data first, solution for this given data, R2 equals direct values, R2 equals 0.01 and X2 equals to 0.035. So these two are okay. I2 you calculate it. And cos 0.8, cos phi equals to cos phi 2 equals to 0.8, and from this sin phi 2 equals to square root of 1 minus cos square theta 2, that equals to square root of 1 minus 0.8 square equals to 0.6. So sin phi 2 and cos phi 2 is okay. Next, supply voltage is 220 volts. Supply voltage is 220 volts means this is V1. So from this is V1 only. So from we need V2. So full load voltage. So calculate the full load voltage and I2, then you will get. So first equivalent impedance refer to the primary. So that I will explain first. After that this one. Next. So I2 02. So don't R2 means here refer to the secondary terminal. So R2 02. I2 R2 only. I2 R02 and X2 02. So now here turns ratio N2 by N1. Here N2 is 80. This is N2 by N1. N2 by N1. This one, that equals to 1 by 5. This one 1 by 5. So turns ratio equals to 1 by 5, that equals to 0.2. Now here the equivalent resistance refer to the primary. Here R1 equals to this one, and refer to the primary means R101, and refer to the secondary primary RX01, and this one is the impedance. These parameters equivalent impedance refer to the primary. So first refer to the resistance primary means here R1 plus R2 by K square. Here R1 is this one and R2 is this one, 0.3 and 0.01 divided by K square. K means this one, 1 by square 0.2 square, that equals to R01 equals to this one 0.55. Next X2 equals to this one 1.11 plus 0.035 by 1 by 1 by 5 square, that equals to 1.19 square. Now this is resistance X01 and this is the resistance R01 0.05 and X01 1.975. So this is R01 and X01. So Z equals to R plus JX. Z equals to R plus JX, this formula. So now we have impedance. So this one is okay. Now percentage regulation, for that we need. So now so here R202 and Z2 X202 we need. So for that purpose Z, this is the equivalent resistance refer to the primary first. So equivalent resistance refer to the secondary means, so there is a formula. If you know the equivalent resistance refer to the primary and this turns ratio, then you can determine equivalent resistance refer to the secondary. So from that you can find out, so 1 by 5 whole square and refer to the primary. So this is the R2 plus JX2, J02, and this equivalent resistance refer to the primary and equivalent reactance refer to the secondary, and refer to the secondary resistance, refer to the secondary, and impedance refer to the secondary. It is in rectangular form. So now here R202 is okay, and this R2X0 X02 okay. Now here no load secondary voltage here. No load. This is the primary voltage only. Primary voltage. There is a relation V1 by V2 equals to V2 by V1 equals to there is a K turns ratio. Now here V2 equals to K into and V1. Here V1 equals to, this is 1 by 5 and this is 2200, this one. And so from this there is a secondary voltage. This is required here. V2 is calculated. So now how you will calculate the I2? This is not 10 power 103, 10 power 3. So 10 power 3, this one. So not 103. There is a printing mistake. And now here this is 100 kVA transformer. So I2 equals to kVA rating divided by this 440, that equals kVA rating means, so 100 into 10 power 3 divided by 440, and that value equals to 227.3 amperes. Now here we have the regulation formula. Voltage drop equals to I2 R02 cos phi and minus Ix02 sin phi, that equals to this I2 and R02, this one, and this is cos phi, and this one, and sin phi is 0.6, and this is the X02. So this is the resistive voltage drop from no load to the full load. And next percentage regulation equals to this resistive drop divided by 440 into 100 equals to minus 1.54. This is the percentage regulation. And secondary terminal voltage, this is the resistive drop. So secondary terminal voltage equals to, so secondary terminal voltage on full load, so E2 equals to, so now here on load equals 440 minus of minus this one equals to 444.77. So now this problem is over. So I derived the voltage regulation of transformer, and I solved 3 to 4 problems on this voltage regulation of our transformer. If you still, I hope these problems and this derivation is clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.